Om Namah Shivaya. Bharat Mata ki Jaya. Seetharam Jayam. Kali Mata ki Jaya. Saraswati Mata ki Jaya. Gauri Mata ki Jaya. Shri Ram ki Jaya. Samaya Sharanam Ayappa. I am Sarath C, coming from Kallara, Thiruvananthapuram, Kerala, South India, Bharat, and I warmly welcome all of you to the Sarath C Aviation and Rail Knowledge YouTube channel. Today, we are presenting a special seminar section that investigates two major topics. First, a complete analysis of ISRO's GSLV-F-16 rocket launch held today, and second, the full technical seminar report on the NISAR Earth Observation Satellite, jointly developed by ISRO and NASA. Let us begin with today's historic space event, the launch of GSLV-F-16, conducted by ISRO, Indian Space Research Organization, from Satish Dhawan Space Center, SDSC, Sriharikota. The GSLV-F-16 mission involved the deployment of a high-precision Earth observation satellite into a geosynchronous transfer orbit, GTO. This satellite is expected to play a vital role in climate research, natural disaster monitoring, and agricultural planning. The GSLV-F-16, using the Mark II configuration, was powered by solid, liquid, and cryogenic stages, demonstrating ISRO's continued reliability in medium-lift launches. The successful ignition, stage separation, cryogenic performance, and orbital insertion were confirmed through telemetry tracking and ISRO ground stations, reflecting India's advanced command and control systems. The full technical investigation of today's launch reveals multiple mission-critical highlights. The solid first stage, S-139, fired for approximately 110 seconds, followed by two L-40H liquid strap-on boosters. At an altitude of over 130 kilometers, the CUSP cryogenic upper stage, fueled by liquid hydrogen and liquid oxygen, ignited flawlessly and injected the payload into its intended elliptical orbit. Real-time data showed accurate attitude control, stable roll-pitch yaw correction, and nominal GTO injection. The satellite will now perform orbit-raising maneuvers using onboard propulsion, gradually shifting into geostationary orbit, GEO. This event marks India's growing capability in climate and terrain-specific satellite missions and strengthens national readiness for future deep space and interplanetary ventures. Now we shift to the second major segment of today's seminar, the NISR satellite mission, a global-scale collaborative project between ISRO and NASA. The NASA-ISRO Synthetic Aperture Radar, NISR, satellite is one of the most ambitious Earth science initiatives in recent times. This dual-frequency radar satellite, equipped with L-band radar from NASA and S-band radar from ISRO, is built to deliver the most accurate terrain and environmental measurements ever taken from space. The L and S-band SA, synthetic aperture radar, systems are designed to penetrate clouds, vegetation, and even ice to observe ground movements, deforestation, glacier melting, ocean dynamics, agricultural change, and seismic activity with unprecedented precision. From the Indian side, ISRO is contributing the satellite bus, S-band radar, launch services, and mission control from Sriharikota, while NASA contributes the L-band radar, large deployable antenna, and precision electronics built by the Jet Propulsion Laboratory, JPL. The satellite is planned to be launched aboard the GSLV Mk2 or Mk3 rocket, and will be inserted into a Sun-synchronous low Earth orbit, LEO. The mission will cover the entire globe every 12 days, generating consistent, repeatable data that is invaluable for scientists, governments, climate analysts, and agricultural researchers worldwide. Technically, NISR will use interferometric synthetic aperture radar, NISAR techniques, which allow it to take repeat radar images of the same ground location and detect microscopic ground deformations such as landslides, earthquakes, or tectonic plate shifts. This has real-world applications in disaster preparedness, urban development, and water management. With climate change accelerating, such missions are no longer optional, they are urgent tools for survival. The joint mission also symbolizes a landmark space partnership between India and the United States. Both nations share data, technology, and expertise to benefit humanity at large. ISRO's precision in launch vehicle design and ground station support complements NASA's advanced radar engineering and global Earth science network. The mission's data will be openly available to researchers, ensuring scientific transparency and international cooperation. NISAR is also a great opportunity for Indian students and youth to explore careers in remote sensing, space systems engineering, geospatial data analytics, and climate intelligence. Together, today's GSLV-F-16 launch and the upcoming NISR mission represent the strategic transformation of India from a launch service provider to a global science leader. They highlight India's mastery over launch vehicle technology, international collaboration, and data-based global problem solving. Whether it's tackling climate change, managing land resources, or predicting floods and droughts, these missions equip our nation and the world with space-based solutions. I am Sarath C, and this has been a special seminar session on the ISRO GSLV-F-16 launch and the NISR Earth Observation Satellite mission, a combined story of Indian pride, scientific brilliance, and international space cooperation. Thank you for being part of this exploration through the Sarath C Aviation and Rail Knowledge YouTube channel. Stay connected for more in-depth seminars, launch analysis, and space science investigations from Bharat and beyond. Jaya Hind, Jaya Bharat, Om Namah Shivaya.